Hi students, my name is Nagendra Babu. My qualification is MSc BD. So I have been teaching mathematics since 1998. Today I am going to introduce the first chapter of state syllabus 9th class real numbers. By watching my previous videos, somebody asked to tell the concepts from 9th class mathematics. That's why I want to share the introduction of this chapter to you. And also, in the next month, you are going to attempt FA1 examinations. So, in the syllabus, the first chapter is very important for FA1. That's why I want to discuss some important and difficult topics of this chapter to you. That is, representing the real numbers on the number line. Before that, let us have clarity about the terminating decimals, non-terminating decimals, recurring and non-recurring decimals. What is meant by termination? Termination means closing. That is, suppose if we divide 11 by 2. Here 2 5s are 10 and 1 is remainder. Convert this into decimal form. That is, put point and take 0 here. Again 2 5s are 10. This is remainder 0. So up to here the division closed. Closed means terminated. After getting the remainder 0, we call it as terminating decimal. If the division completed, we call it as terminating decimal. If the division does not complete, then that will be the non-terminating decimal. Here the division terminated, that's why we call it as terminating decimal. So 5.5 is terminating decimal. Suppose if 20 is divided by 3, 3 6 are 18, remainder is 2, put point and take 0 here. Again 3 6 are 18, remainder is 2, take 0 again. If you go on to like this 6 6 6 and so on, this will not terminate. Division continued. So this is called non-terminating decimal. Here the division is not completing, it is repeating. So this is non-terminating decimal. At the same time, here in the quotient 6 is repeating. Repeating means recurring. We call that repeating as recurring. So 6 is recurring here. This is non-terminating decimal. At the same time, recurring. So this is called as non-terminating recurring decimal. This is terminating decimal. 5.5 is terminating decimal. Suppose 4 is divided by 7. So 4 does not go by 7. Take point here and put 0. 7 5 is 35. Remainder is 5. Already point is there. So take 0 again. 7 7s 49. And 1 is remainder. Take 0. 7 1s are 7. 3 is there. So take 0. 7 4s 28. Remainder is 2. Take 0. Again 7 2s 14. 6 is remainder. Let us continue that here. 6 is remainder. So already point is there. Take 0. Again 7 8s are 56, 4. Again take 0. And from this, the division is, the quotient is repeating. From here, the quotient will repeat. That is 0.571428. Again from 4, the division starts. So again we will get 571428, 571428, 571428 and so on. So what is happening? 571428 is repeating. That's why this is not terminating, not closing. Division is not closing. That's why this is non-terminating decimal. At the same time, 571428 is repeating. That means 571428 is recurring. That's why we call it as non-terminating recurring decimal. What is recurring here? 571428, 571428, 5714 is repeating. That's why we write it as 0.571428 bar. 571428 bar. So here 6.666 and so on. This can be written as 6.6 bar. This is non-terminating recurring decimal. This is also non-terminating recurring decimal. Okay. Let us do this division. Divide 39 by 4. That is 4 9s 36 and the remainder is 3. Put point here and take 0. 4 7s 28 and 2 is remainder. Already taken point there and put 0 here. So 4 5s are 20. Remainder is 0. So here the division closed. That's why we call it as terminating decimal. Let us learn how to represent this terminating decimal on the number line. We all know very well how to represent the integers on the number line. Integers on the number line. Let us have a look the integers on the number line. So take 0 here, 1, 2, 3, 4, 5 and so on. On the left side, -1, -2, -3, -4, -5 and so on. So all these are integers. Positive integers on the right side, on the left side negative integers. So all these integers can be represented on the number line like this. This you all know very well. You learned this in 6th class. In this class, let us learn how to represent these decimal numbers, terminating decimals on the number line. Let us take an example. Okay, this is the number line with integers. These are positive integers and these are negative integers. We have to represent 6.835 on the number line. This 6.835 lies between two integers 6 and 7. Look at this clearly. 6.835. 6.835 lies between 6 and 7. So, on any number line, let us write the numbers between 6 and 7. The numbers between 6 and 7. Because the 6.835 lies between 6 and 7. So, let us take another number line with the numbers between 6 and 7. Okay. The rational numbers between 6 and 7 are 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9. So, this is the number line with the rational numbers between 6 and 7. Okay, here 6.835 given terminating decimal is 6.835. Now, after decimal, let us see the first digit, that is 8. So, next we have to select the rational numbers between, we have to mark the rational numbers between 6.8 and 6.9, because the first digit is 6.8. After point, first digit is 8. So that's why on the next number line, we have to write the points, the decimal numbers between 6.8 and 6.9. So let us take the numbers between 6.8 and 6.9 on the next number line. The rational numbers between 6.8 and 6.9, between 6.8 and 6.9 are 6.81, 6.82, 6.83, 6.84, 6.85, 6.86, 6.87, 6.88, 6.89, and the last one is 6.9. So this is the number lines with the rational numbers between 6.8 and 6.9. So this is 6.8 and this is 6.9, and all the middle terms of 6.8 and 6.9 are these 6.81, 82, 83, 84 and so on up to 89. Now once again look at that given sum. 6.835. 6.835. Now the rational numbers to be taken on the next number line are, for that look at this second digit. 6.835, second digit is 3. So we have to take the rational numbers between 6.83 and 84. By looking at the second digit, we have to take the rational numbers between 6.83 and the next one 84. That is 6.83 is this and 6.84 is this. So on the next number line, we have to take the rational numbers between 83 and 84. What are those rational numbers between 6.83 and 84? 83 and 84. The rational numbers between 6.83 and 6.84 are 6.831, 6.832, 6.833, 6.834, 6.835 and so on. So let me draw the next number line with the rational numbers between 6.83 and 6.84. Okay, the rational numbers between 6.83 and 6.84 are 6.831, 6.832, 6.833, 6.834, 6.835, 6.836, 6.837, 6.838, 6.839. So all these are the rational numbers between these two. Now what we have to represent is 6.835. So we got this rational number on this number line. Where is that 6.835? This is 6.835, and draw a box highlighting this answer. So 6.835 is represented on the number line. Like this, we can represent any terminating decimal on the number line. So let us take another example and draw the number line. So this is the number line with integers. This is 0. In the right side, positive integers, and on the left side, negative integers are there. So to represent 4.6767 on the number line, first of all, we have to take the rational numbers between 4 and 5. The ratio, this starts with 4. 4.6767 starts with 4. So we have to take first the rational numbers between 4 and 5. This is 4 point something. That's why we have to take the rational numbers between 4 and 5. Next, this is the number line with the rational numbers between 4 and 5. What are the rational numbers between 4 and 5? 4.1, 4.2, 4.3, 4.4 and so on, 4.9. Those are the rational numbers between 4 and 5. So on this number line, we have rational numbers between 4 and 5. Next, once again look at the given question. That is 4.6767. We have taken the rational numbers between 4 and 5. Now look at the first digit after decimal. That is 6. That's why we have to take the rational numbers between 4.6 and 4.7. First digit is 6. So we have to take the rational numbers between 6 and 7. After that, on another number line, the second digit is 7. That's why we have to take 4.67, the rational numbers between 4.67 and 4.68. So, looking at this digit, this is 6, we have to take rational numbers between 6 and 7. This is 7, then we have to take rational numbers between 7 and 8. Next, and again, here 6 is there. So, we have to take rational numbers between 6 and 7. Again 7 is there, between 7 and 8. Like that, we have to choose the number line. So, let us draw another number line with the rational numbers between 4.6 and 4.7. So, this is the number line with the rational numbers between 4.6 and 4.7. Those are 4.61, 4.62, 4.63, 4.64, 4.65, 4.66, 4.67, 4.68 and 4.69. Now look at that question again. 4.6767. So this is drawn according to the first digit after the decimal. Now look at that second digit. This is 7. So we have to draw the numbers between 7 and 8. That is 4.67 and 4.68. According to second digit after decimal point. We have to take those numbers. So here the second digit is 7. That's why you have to take the rational numbers between 4.67 and 4.68. So let us draw the number line with 4.67 and 4.68. Now we have drawn the number line with rational numbers between 4.67 and 4.68. So those are 4.671, 4.672, 4.673, 4.674 and so on, 4.679. Now 4.6767 is the given number. Now look at the third digit after decimal, that is 6. That's why we have to take the rational numbers between 6 and 7. 6 and 7 means 4.67616 and 4.6767. Rational numbers between 4.676 and 4.677. Let us draw another number line with the rational numbers between 4.676 and 4.677. Now this is the number line with the rational numbers between 4.676 and 4.677. They are 4.6761, 6762, 6763, 6764, 6765 and so on, 6769. Now 4.6767 we have to represent on the number line. Where is that 4.6767? Here it is. So highlight this 4.6767 by drawing a box like this, and this is represented on the number line according to the question. So what is the question asked? Represent 4.67 bar on the number line up to 4 decimal places. Up to 4 decimal places means by expanding 4.67 bar you will get 4.676767 and so on. He asked up to 4 decimal places. That's why we took 4.6767 and represented that on this number line. So students, I think you understood how to represent the terminating decimal on the number line. If you have any doubts, feel free to ask by commenting in the comment box. And if you want to give any suggestions also, post your suggestions in the comment box. Like this video, share this video to all your friends, subscribe my channel, and don't forget to hit the bell icon to get many more notifications regarding the classes, mathematics classes from 6th to 10th class. In the next video, I will come with another concept of this chapter, real numbers of 9th class, that is rationalizations. Thank you all very much.